Hello. Today's mini lesson, I should say, will be on distributive property. Now, this topic may be a review for some of you. For others, this is a relatively new topic. And okay, so I'll get right with it. One of the benefits of knowing and using distributive properties, we should be able to deal with these kinds of problems that we have listed here. I don't need to do that. Okay, so for instance, let's read the problem. 4 something parenthesis 3y minus 5. Well, what is that? What is the sign in between 4 and the parenthesis? If the sign is missing there, it's always assumed that what it is a multiplication sign. So what we're doing is 4 times the group with the parenthesis 3y minus 5 close paren. In the second problem we have it's negative 2 times the parenthesis, what's inside it. This is a group of, it could be thought of as one quantity. Okay, so the distributive property helps you deal with these kinds of problems. Now, the problem number 3, it doesn't look the same as the first 2 problems, but it really is an application of distributive property. Actually, it's a double application of it. Now, in this particular course, we may not be able to get to this topic. I'll just leave it like this. I'll just leave that's a multiplication, and yes, for this kind of problem, it is a distributive property that we're actually using, but it is more challenging, and I'm not gonna cover it in this particular lesson. All right, before I show you the actual mechanics of solving these kinds of problems, I'd like to give you some background or give you some sort of logical reasoning why distributive property works. And for that, I'd like to use the prop of the following. Let's pretend we have 2 identical boxes. Each box has, it has 1, 2, 3, 4, and this one 1, 2, 3, 4. So each box has 4 circles, and each box is 1, 2, 3, 1, 2, 3, 3 triangles. And let's say the problem involved, or the question involved was, well, what is it that I have in total? What kind of, how many and what kind of objects do I have? One of the ways of doing it in real life, you simply, you take everything out of boxes, and here it is. So here's the 4 circles from the first box. 1, 2, 3, 4. 1, 2, 3, 4 from the second box. Then from the first box you have 3 triangles, and from the second box you have 3 triangles. Now, next step is just kind of to show you where we're going. I simply rearrange the physical position of them to kind of group them together. So in other words, I took this group of 4 circles and I brought it together with these circles. And this particular group of triangles kind of went with this group of triangles. So once I rearrange, and I just basically count, what is it that I have? 1, 2, 3, 4, 5, 6, 7, 8. I have 8 circles, and I have 1, 2, 3, 4, 5, 6 triangles out of both of these boxes. So, but in mathematics, I kind of tend to think of it as, oh, come on, why isn't it moving? There it is. So instead of writing 8 little circles together, I could just write 8 circle. That represents that it's this represents what I have is 8 circles, and instead of writing six individual triangles, I just write 6 and a little representation of 1 triangle, indicating that I have in total I have 8 circles plus 6 triangles. Believe it or not, that's an application of distributive property. But in terms of mathematics, I would like to think of it this way. Instead of writing 2 individual boxes, I could just say, well, since each box is the same, I really have 2 boxes 2 times this same box. In terms of math, this translates 2 and then times, and the box is represented by the parentheses. See, as you see, well, ugly parentheses. Anyway, so what I have inside of the box could be thought of as well. This is inside the box. So, but let's say if I use the still, going back to the box part, what I have is two groups of four, 4 and two groups of 3 triangles. Anyway, so just like before, when I took everything out, I rearranged. I simply that's what I'm showing right here. And all that's once I take things out of the box. In terms of math, I have 2 times this group right there. So one way to do this is really 2 times 4c, I would get 8c, and 2 times 3t, which would gives me 6t. As you can see, the same result as before. We have 8 circles in total and 6 triangles in total. As you know from combining like terms, you can't combine circles and triangles, just like you can't combine variable c and variable t. C stands for circle in this case, and T stands for triangles. But in terms of algebra, in terms of math, they could stand for anything else. This is just a visual representation of this particular problem. Alright, so as you can see, once we understand how distributive property works, we can simply apply it without even thinking too much about it. So in this particular case, we have a problem 4 times the quantity of 3y minus 5. That's that's basically, think of it as that one box or one group. The way we do that is we apply this 4 times this number and then 4 times this number. So what is 4 times 3y? Well, that's 12y. And what's 4 times, I don't know, you can think of it as -5 or -5, whichever way you want to think about it, but it's really going to be minus 20. Because 4 times 5 is 20, but you have this minus in front of, therefore that's the minus that has to be in front of 20. So mechanically, there's your answer. You simply multiplied, and I'll do it again. You multiplied 4 times this, and then 4 times this. Okay, so now in this particular case, we had 2 terms inside the parentheses, but you shouldn't be limited just to number 2. It could be a whole bunch of stuff in that box. And I give you an example down below where my box, or quote unquote, but the parentheses includes 3 terms. So, but the mechanics are really the same. So I take whatever's in front of, let's just also re-indicate, even though you should understand that's really multiplication sign, but I'll just clarify that. So what I have here is -2 times 4x is what? It is -8x. Okay, I'll switch colors. What about -2 times this? -5y. Well, that becomes positive 10y. And last one, what about -2 times that very last term of +9? Well, that becomes minus 18. That's just a constant. It does not have a variable attached to it, but that's fine. So just to recopy what I have here in terms solidified in one color, the answer is -8x plus 10y minus 18. And again, we cannot combine x's and y's together because they're not like terms. Therefore, this is my final answer. There's nothing could be done to simplify that. Now that pretty much covers distributive property and its application. The only thing I want to add to it is students have a difficult time with this kind of problem. If I have minus, or I don't know, 3x plus, I don't know, 2y minus 5, let's just say that. Whereas before, it looked like I had a number here in front. Now I have just simply a minus sign. Well, what does that mean? It could be thought of as two ways, but they're both going to give you the same answer. You can think of this negative sign as simply, well, it negates, it flips the sign of whatever's inside. It flips individual terms, each term sign. It flips it to its opposite. So if we started off with a positive here, this is a positive, right? That will become a negative. This is a positive, that will become also negative, and this negative will become a positive. So simply with this minus sign, minus in front of the parenthesis, which is represents some box, if you will, it just means that the final answer will be minus 3x minus 2y, and then we flip the sign of the negative 5 will become positive 5. There it is. Now, another way of thinking about it really has the same effect. You know what? I'll just leave it at that. Because I don't want to confuse you. You practice this a little more, you'll be clear on it, and there's sometimes no need to introduce another way of thinking about it, especially in the very beginning. Okay. So, okay, that pretty much covers today's lesson. Thank you.